Alright, just in case you missed the warm-up, the answers were x squared equals 144. If we were going to solve for x, you would have to square root both sides. And so x could be 12. But since we're not sure if this is distance or anything, x can also be negative 12, because 12 squared is 144, so we can show that. And then negative 12 squared is also 144. Notice how I put that in parentheses. You'll see that come up today, but we will be talking about distances. So number 2, you had to sketch. This is exponential. We've talked about those, and you'll see them on your final. So exponential, the y-intercept is 0, 5, so I would be checking to make sure you started there. And it's dk because the 0.5 is between 0 and 1. Okay? So I would check your y-intercept, and then I would check to make sure that you decayed. Alright, and then the last one, you're just finding the slope. So you're just using the basic slope formula. So we did 23 minus 11 over negative 4 minus 4. This became 12 divided by negative 8, and then if you simplify that, it simplifies to negative 3 over 2. Okay? So that's in case you missed the warm-up. On the back, you are giving the x and y intercepts of these two equations, and you will see also this on your final. The y-intercept is, or the x-intercept is when y equals 0. So what you could do is you can just cover up that y and say, hey, you're just going to have 3x equals 36, so x equals 12. So then your x-intercept is 12, 0. Then your y-intercept is when x equals 0, so you wouldn't have this x term, and you'd be left with negative 4y equals 36, and then y equals negative 9, so then your y-intercept is 0, negative 9. Okay, over here, your x-intercept, again, is when y equals 0, so you would have 1/2 x equals 30. To get rid of a fraction, you multiply by the reciprocal, and so 2 times 30 is 60, so that's where we got the 60, 0. And then the y-intercept is when x equals 0, so you have 6y equals 30, and 5 is y, which you would divide by 6. Okay, so just a little refresher of stuff that you will see on your final. Okay? Your objective today is the students will learn to solve real-world problems involving quadratic equations in order to make predictions about scenarios. So before we start this, I just want to go over some basic of what is a quadratic. So you can see on the left of your paper you have all the quadratics. Hopefully you know by now that it is a quadratic because of the x squared. Okay, so the highest degree is the x squared. So in your definition, you could write something like, I'm going to have to make the font much smaller. Okay, so it's an equation where the highest degree is 2. So highest degree means the biggest exponent it has is the 2. Okay, so you can see on this side you have, a degree of 1, degree of x, degree of 3, and this is actually a negative 2 if you were to put it up. You also want to make a note of what happens. So in here, a is 1, but here a is negative 1. Okay, we've talked about this before. If a is greater than 1, your parabola opens up. Okay, and that means you have a minimum. if A is less than 1, your parabola opens down. Oops, I should put a little less than 1. So if A is less than 1, your parabola opens down and you have a maximum. Okay? So this is just to get you to see, the difference between a quadratic, which forms a parabola, and then non-examples, which can either form a line or cubics. Okay? So the back of this, you're basically, all you're going to be doing in this lesson is taking an equation that they're going to give you and substituting variables in and solving for certain variables. The trick is to just make sure you substitute into the correct variable. So the equation d equals 1/16 times s squared, so that's your equation, is the equation used to find the stopping distance. So a lot of times I highlight or underline what my variables mean. So d is distance needed for a vehicle traveling at a speed of s, because now that we're in the real world we have to have labels. Your first question says find the stopping distance needing for someone to drive at a speed of 65 miles per hour. So you can see that they give us s and they want to know the distance. So all we're doing is plugging d equals 1/16 times 65 squared. And to be on the safe side, I would also put 1/16 in parentheses. So we have 1 divided by 16 times 65 squared. Okay, and we get 264.0625. Let's round. A lot of these we're going to need to round to the nearest unit. So we'll do d equals 264, because that would be the nearest whole number. Okay, and d was feet. Okay. In the next one, they're asking to find the speed. Okay, so this time we don't know s, and we have to solve for s. So if you want to make a note, maybe put like s question mark. Okay, this time up on part A, it was d question mark, because that's what we were finding. So they give us the distance. It took 144 feet to stop. So if we do 144 equals 1/16 times s squared. So to get rid of this 1/16, we multiply both sides by its reciprocal, so times 16. Okay, hopefully you realize that 144 times 16 is 2,304 equals s squared. And in order to solve for that, to undo the square, you have to square root. So we get s equals 48 miles per hour. Now before, when we had the 12, we gave us a -12, but because we are in speed, you can't have a negative speed, we only need the positive. So that would be 48 miles per hour. It would take you 144 feet to stop. Okay? Number 2, the people in geometry. Shout out to some of my favorite geometry students. You should definitely know how to do this one, because number 2 is the equation for area of a circle. Okay, so area equals pi r squared. And in the first one, they want you to find the area of a circle with a diameter of 12. Well, notice there's no d in that formula. So hopefully you realize that diameter is 2 times the radius. So the r would be 6 inches. Okay, and then it wants you to find the area. So it might be like a question mark. A equals pi. Happy Pi Day, everybody. I'm making this video on Pi Day. Pi times 6 squared. And you can just plug this in on your calculator. To get the pi, you do second caret and then 6 squared. Alright, and let's round that to the nearest unit. So that would be 113. And it would be inches squared. Okay? Okie dokie. So I'm going to be circling my answers. I forgot to up there. All right, and number 2, find the radius of a circle having an area of 615.75 square inches. So this time it says find the radius. So we're solving for R. And they give us the area. So we know 615.75 equals pi r squared. All right, lucky for us, pi is just a number, so we can divide by pi. Just treat it like it was a 5 or a 4 or something in front of a variable, because that's going to be gone, and we can do 615.75 divided by pi. Okay. 195.9993124. Let's round that up to 196, and you'll see why I do that in a second. Because we now need to undo the square. To undo the square, we square root, and magically 196 is the perfect square, so our radius equals 14 inches. And no, we can't have a negative radius, so we're not going to use negative 14. Alright, so those are 2 questions you might see. Notice we didn't graph anything yet. We will be graphing on the next page, so please make sure you stay tuned and have your calculator ready. Alright, and number 3, a hammer is dropped from a 2nd-story rooftop 18 feet above the ground. There is your equation. We know h is the height in feet, and t is time in seconds. Okay, so find the height. So again, it's asking for the height, so height question mark, after 1/2 of a second. So they give us t. T will be 1/2 of a second, which is 0.5, and all we're doing is plugging and chugging. So negative 16.5 squared plus 18. And I would plug and chug just like I see it on my calculator. Negative 16.5 squared plus 18. So after a 1/2 second, the hammer is at 14 feet. Alright, then we want to know how long was the hammer in the air, so we have to figure out a t. Well, the hammer is in the air the whole time. The hammer's in the air, obviously, and time goes by. So if it's dropping from a 2nd-story window, so assume it's dropping from somewhere up there, and it's going to drop, whoop, and say that's the ground. That means it dropped when it hits the ground. So that would be when h is 0. Okay? So let's substitute that in and see what we can solve. H is 0, so 0 equals negative 16 t squared plus 18. Alright, we eventually want to solve for t, so we just solve the equation, take away 18 from both sides, and now we are at, I'm going to come over here, negative 18 equals negative 16 t squared. So just like you divided by that pi to get rid of the variable, or to get rid of the number, you can divide by negative 16. Alright, we get, let's keep this at 1.125 equals t squared, square root, so hopefully you can see a lot of the stuff we do the same, and we get t equals, let's see how we want to round this. So the square root of 1.125, let's round that to 1, I guess. 1 second. So after 1 second, it hits the ground. Okay? So at 1/2 second, it is at 14 feet, and about at 1 second, it's on the ground. Alright, so here's the one where we're going to need to use our calculator to find a lot of our mins and our maxes, unfortunately. I remember you guys don't really like that. So, a toy rocket is launched from the initial height of 1.5 meters, has a velocity of 10 meters per second. The equation is this, used to find the height of the rocket, in meters this time, at t seconds, okay? So use your calculator, so that's kind of like your hint, like, oh, I need to use my calculator, to estimate the maximum height of the rocket. So what I'm going to do is go into my y equals. Okay, I'm going to clear out anything that's in there, and I'm going to type in negative 4.9 x, oh, did I use a negative? No, I think negative 4.9 x squared. Alright, I'm just going to click the buttons. Hopefully you're doing this as well. X squared plus 10x plus 15. No, it's 1.5, right? Alright, plus 1.5. Graph. So if your graph does not come up like mine, hit zoom 6 and then it'll come to a standard fit. So you can see that hopefully you also saw that a was less than 1 because it's a negative number. So the parabola faces down and we have a maximum. Okay? So the maximum height, that is going to be, we're going to get a maximum. So you're going to go to second trace, which gets you to calc, and we're going to hit maximum. Okay? Second trace maximum. So you can see the blinking thing. It's asking to be to the left, so we need to be to the left of the max. Hit enter, and then scroll over, so you're now to the right of it. And then you have to hit enter twice. Okay, so you can see, I'm just going to write this coordinate down as 1, 7. I rounded to the nearest unit, which we've been doing, because we're going to need both numbers. So 1, 7. So the y here represents the height. So the height was 7 meters. Okay, so it was about 7 units or 7 meters at the top of that parabola. The time is the x. Normally time is x in most cases. So when the rocket reached its maximum height, that's going to be about 1 second, because that was the x coordinate of the maximum. Alright, so your big keys here are use your calculator, which means you're finding the maximum. You might have had to find the minimum, whichever one, if the question changes. But using your calculator, that can clue you in. You might need to find the max or the min or the zeros. Because moving into question C, it's how long the rocket was in the air. Well, if you're, in the real world, we can't go underground. So in the air, it stops right there on your graph. Okay, so that's 0. So when t equals 0. So here it starts at the ground, it goes up, and then it comes back down, and now it's done. Okay, so we're going to calculate that 0. Second calc, 0. We got to be to the left of that one, so we already are. And then you're going to scroll. Even though I went off the screen, I'm still to the left of it, so I just hit enter, enter. Alright, you might have 0 right there. That just means it's really, really close to 0. Sometimes the calculator will make that 0. Okay, so let's round this to 2. So it was 2, 0, which means the rocket was in the air for about 2 seconds. Alright, so in part A, we calculated the max. Part C, we calculated the 0. And since we're in the real world, if you're looking at a lot of your graphs, you're really only going to be concerned with that first quadrant because we won't have a negative time and we won't have a negative distance. So you can kind of use your calculator to eliminate some of the answers. All right, so what you have to do now is you have to, hopefully your notes are all complete. Then you have to do the Unit 8 Day 1 classwork. Again, I highly suggest you get it done today so that you don't get behind, and it's the beginning of the unit and it's a shorter unit. So you want to kind of keep up with the expectations of the class. And if you do that, you should be just fine.